All right, the last video. Can you tell if I'm laughing or crying? Anyway, so we are going to conclude with some special polar graphs. Now, I'm going to let you know in advance because I know you're going to probably freak out when you see all this stuff. I know my audience. You do not need to memorize any of these names or any of these equations. It's just something we want you guys to be able to recognize, understand. I'm going to include the word appreciate, and potentially graph. Some special polar graphs, not all. Okay? So, let's take a look at the first special polar graph. The first one is called a limacon. I don't know. However you want to pronounce it is the way it's supposed to be, right? So, how about limacon? Sure. So, the graphs are r equals a plus b sine of theta, r equals a minus b sine of theta, r equals a plus b cosine of theta, and r equals a minus b cosine of theta, when a is greater than 0 and b is greater than 0. These are called limacons. The ratio a to b determines the limacon's shape. So let's take a look. I still don't know why this is here. I'm sorry. It's really not cool, but whatever. So in general, all these have a pretty similar shape. Now, these are all examples of cosine graphs. How do I know that? Because of its symmetry. Kind of referenced that in the last video. But like it was saying before, depending on the ratio of a to b, it might have an inner loop, it might have a heart shape, it might have a little dimple, it might not have any dimple or inner loop. So it's just kind of a cool thing to see. You know, if you were wondering what it would look like, I mean, you could always, as always, you know, make sense of it if you just pick some values and graphed it. But it's just kind of cool to see. You know, a type of question you could be asked on this is maybe like you're given a graph and then you're given some possible equations for the graph. Which one would it be? I mean, the biggest thing would be able to tell the ratio from A to B. So, pretty cool. Limacon graph. All right, next one, rose curve. Oh yeah. We actually saw this graph in the previous video, this exact one. Do you guys remember? Cool. Means you liked it. But yeah, this is a rose curve. Looks really pretty. Yep. Okay, so rose curves. The graphs r equals a sine of n theta and r equals a cosine of n theta. But a can't equal 0 because then this would just be 0. That makes sense. So these are all examples of rose curves. Now, how do we know how many petals it will have? Because it's a rose, it has petals, you know. So as it says here, if n is even, then the rose has 2 n petals. And if n is odd, the rose has n petals. So here are some examples. Again, I apologize for this stupid thing. It's really angering me. Okay. So here's a curve that has 4 petals. Since it was even, it's 2 times n, right? Here, since it's odd, it's just 3 petals here, 4, so it's 4 times 2, so 8, and then this is odd, so just 5. I also want to point out the symmetry. If you guys look at the ones with sine, notice that they're all symmetric with respect to pi halves. Also, the cosine ones are symmetric with respect to the polar axis. Now, this one you might be like, oh, but it's symmetric with respect to pi halves. Yes, but because it's cosine, it's primarily symmetric with respect to the polar axis. My point is sometimes you could get cosine ones that are symmetric with respect to both. Just something to keep in mind. All right. Last special polar graph. Lemniscates. I don't know, whatever you want to call it. The L one. Okay, I guess that was not funny. But this special graph here, it's the graph of r squared equals a squared sine of 2 theta and r squared equals a squared cosine of 2 theta. These are the Lemniscate graphs. Now, here's an example. Of course, that had to happen in the last video, right? Otherwise, it wouldn't be like one of my videos. But anyway, the Lemniscate of r squared equals a squared cosine of 2 theta. It looks like this. Infinity symbol. Pretty sweet, I know. Notice that it's symmetric with respect to the polar axis. That seems understandable. But yeah, it's pretty cool. So in conclusion, back it up here, T. Come on. In conclusion, this computer's being a little slow today, so I apologize. We have circles, limacons, whatever you want to call them. We have rose curves and the lemniscates. Remember, you do not have to memorize these, so stop freaking out. And then we also talked about finding zeros and tests for symmetry. Thank you all for listening to my voice this year. I know it was not easy. I know it was not enjoyable at times. But, you know, I had the time of my life making these for you. And I could not be happier that it's the last one. Woo!